discovery could rewrite geologic textbooks. And here we're looking at a 500 million year old trilobite fossil, left ladder-like traces. Cambrian worms left tube-like trails in the mud of the shallow ocean that are preserved as trace fossils. And this is from University of New Mexico. Collaborative research integrated innovative analytical techniques with traditional field geology, conducted in one of the world's leading geological laboratories, has provided fresh insights into the Cambrian explosion of life. Earth's 4.6 billion year history, dominated by single-cell life since shortly after the planet's formation, but approximately 500 million years ago, a dramatic event known as the Cambrian explosion occurred, and during this period, an extraordinary diversity of life forms appeared and became preserved in the fossil record. These fossils include major groups of diverse animals that evolved into animal groups still living today, including humans. The recent paper by University of New Mexico researchers and an expanded collaborative team is featured as the lead science article in GSA Today, November 2024 issue, titled The Cambrian of the Grand Canyon, Refinement of the Classical Stratigraphic Model. The Tonto group of Grand Canyon holds a treasure trove of sedimentary layers and fossils, chronicling the Cambrian explosion 500 million years ago, when the first animals with hard shells rapidly proliferated and sea levels rose to develop continents with emerging marine life. This is what Carol Deller, professor at Utah State University, said. Deller was lead author with UNM, adjunct professor and paleontologist Fred Sundberg as co-lead, and co-authors included UNM distinguished professors Carl Karlstrom and Laurie Crossey, James Hagedorn from Denver Museum of Natural History, Nature and Science, Mark Schmitz from Boise State University, and Steve Rowland from University of Nevada, Las Vegas. In addition to research advances, the paper has geoscience education advances that build on the classic model for marine transgression, that's advance of the sea across the continents, developed 50 years ago on the same rocks by Eddie McKee. The McKee model, taught to many geology students worldwide, posits gradual deepening and gradual shifts in sedimentary environments. Our new model for deposition of the Tonto group is much more nuanced, showing a mixture of marine and non-marine settings, breaks or unconformities when no sediment was being deposited, and a much faster tempo of evolution. Even more than before, the Tonto group of Grand Canyon remains one of the most important Cambrian type sections in the world because of its complete exposure, says University of New Mexico distinguished professor Carl Karlstrom. The National Science Foundation Division of Earth Sciences supported the work. Our findings are a reminder that science is in progress, Hagedorn said. Our work in the Grand Canyon, one of the world's most well-known and beloved landscapes, connects people to this science in a very personal way. And further, advanced tools provided new insights into rock sedimentation speeds and offered clues on how rapidly marine species such as trilobites and other early animals diversified. Our new tandem UPB dating methods are refining precise ages for each layer in the succession and with transitions between trilobite biozones, said Schmitz. We're finding that different trilobite species radiated, then went extinct at a very fast sub-million year tempo. This method involves grinding up the sedimentary rock samples and separating out hundreds of hand-sized zircon crystals that were deposited with the sediment. The UPB ratios of the grains are first acquired, that's uranium lead, are first acquired using the preliminary method of rapid dating, when the youngest grains are precisely dated with a more elaborate and precise laboratory method. Sedimentary rocks are hard to date, said Crossey. but the deposition of the sediment and fossils entombed within it must be younger than the age of the youngest grains, so with many dates we can bracket sedimentary ages. Deller says the team's new model, compared to McKee's model, offers key pathways for both students and researchers to reach a deeper understanding of the Cambrian explosion. From the Tonto Group's 500-meter thick strata, we're learning about sea level rise and the effects of catastrophic tropic storms, probably more powerful than today's devastating hurricanes. This occurred in a world without land plants and during a period of very hot temperatures when the Earth was ice-free, said Deller. Sea levels were so high that sediments like the Tonto Group were deposited atop most continents in environments that allowed rapid expansion of animal diversity on Earth. And this is on SciTech Daily from University of New Mexico. Please leave your comments. Thank you for your support. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.